Hey everybody, this is Paul. So a few hours ago I had somebody ask if I could show how to prove this statement by mathematical induction. So that sounded like a really good question to me, so here I am making a video on it. So basically we just have some number raised to some power m, and then that's raised to another power n, and they want to show that that's equal to a to the m times n power. So if we're going to do this by mathematical induction, the first thing we're going to do is the basis step. And so we're just going to check to make sure that this is a true statement for some simple case where n is equal to 1. So we're just going to replace these n's here with the value 1. So let's go ahead and do that really quick. So n is 1, and then we have a to the m times 1. So m times 1 is just simply m. And then anything to the first power is itself. So the left hand side here is a to the m. And the right hand side is already a to the m. So that produces a true statement here. And so we know that this is true for at least one case where n is equal to 1. So the next thing we're going to do is we're going to do the induction step. And so for the induction step, we're basically going to assume that this statement right here is true for the case where n is equal to some number k. So we're going to assume that this is true right here. So what exactly does that look like? Let's go ahead and just write that down really quick. So now we're just going to replace these n's with some arbitrary number k, and we're going to assume that that is true. So we already know that it's true for n equals 1. So now we're going to just assume that it works for every case. So all I did here was I just replaced these n's with k's, since we're just assuming that this is a true statement, or basically that this is a true statement based on n equal to some number k. So assuming that this is true, what we want to do is we want to also show that it's true for n is equal to k plus 1. So if we can show that this statement right here is true when n is equal to k plus 1, based off of this assumption right here, then we've completed the mathematical induction proof. So let's go ahead and look at this situation when n is equal to k plus 1. So now we're just simply replacing these n's with k plus 1. So we have a to the m to the n, which is k plus 1. Is that equal to a to the m times n, or a to the m times k plus 1 in this case? So now let's go ahead and just look at this exponent here. We have m times k plus 1 in parentheses. So we're just going to use the distributive property. M times k is mk, and then m times a positive 1 is positive m. So m times the quantity of k plus 1 is the same thing as m times k plus m. So let's just go ahead and write that down in the exponent here. So this is a to the mk plus m power. And so now basically I want to just do some properties of exponents on this. If we have some base raised to the sum of basically two terms, so we have something plus something else inside the exponent, we can rewrite that as the base times, or sorry, not times, but the base raised to the first term multiplied by the base raised to the second term. So this is just a property of exponents. The base raised to the first term times the base raised to the second term. So we can just go ahead and change that by using properties of exponents. And then this one right here we can do the same thing, but this time our base is a to the m. So we have a to the m, and then the first term is k here. And then we have our base once again, a to the m, and then this term, the second term, is going to be 1. So we just use the same property of exponents on both the left and the right hand side to get these two results right here. And then if we notice, we have a to the m to the first power. So anything to the first power is itself. So really this part right here is the same thing as a to the m. And then notice we have an a to the m here and an a to the m here. So if we were to divide the left and right hand side by a to the m, then this part and this part would cancel out. And so now we're just simply left with this part right here, which is a to the m to the k, and that's equal to a to the m times k. And if you notice here, that is actually the exact same thing as our assumption. So we basically showed that this statement was true for some base case where n is equal to 1. That was the basis step. And then we assumed that it was true for some value of n is equal to some value k. So we're just assuming this is true right here. And then we showed that it's true for n is equal to k plus 1, which is this case. And we're showing that based off of this assumption. So we basically showed that this right here produces this statement right here, which we assumed was true in our assumption step. So basically that completes the mathematical induction proof. It works for the basis case, we assume that it works for all cases, and then we just show that it works for the n equals k plus 1 case based off of the case where n is equal to k. And so basically here, we're assuming this is a true statement. That's the same thing there, and we're done. So anyway, thanks for watching. Tell me what you think about this video in the comments. I appreciate you guys leaving comments and all the positive feedback I've been getting. You guys have an excellent day. Stay tuned for more videos from Learn Math Tutorials, and we'll see you guys next time. If you haven't already, don't forget to subscribe.